So this is the solution of the third problem. The question is, a digital signal 1 or 0 is transmitted through a noisy channel. The received data may be different from the signal sent out. Suppose the transmitter sent out 0 with probability 0.6 and 1 with probability 0.4. When 0 is transmitted, the receiver receives 0 with probability 0.7 and 1 with probability 0.3. When 1 is transmitted, the receiver receives 0 with probability 0.2 and 1 with probability 0.8. And the first problem is find the probability that data 0 is received. And we can see that from the question, the probability of output 0 is 0.6. As shown here, it's 0.6. And the probability of 1 is 0.4, yeah. So if we want to receive 0, the probability equals to, this is 0 is what we need to receive, and when the output is 0, this is the probability when output 0 and we receive 0. And also we need to time with the probability of the output data is 0, and this is the probability when output data is 1 and the received data is 0, and we need to time with the probability of output data is 1. So we can see from here when it's 0 output data and we receive 0, the probability is 0.6, and also we need to time with the probability 0.7. And when 1 is the output data, the probability of 0 is 0.2, and we also need to time with the probability that output data is 1, so it's 0.4. So we can see from here is 0.42 plus 0.08. So the total probability is 0.5. The second question is find the probability of error. For example, the probability that 1 is received when 0 was transmitted, or 0 is received when 1 was transmitted, which means the output data is 1 and we need to receive 0, so that's an error. And the output data is 0 and we need to receive 1, so that's another error. So we need to add because it's independent, so we can direct add these two probabilities. First is the output to be 1 and receive 0 is 0.6, and we also need to time with the probability of output data is 1, so it's 0.3. Also, we also need to find the output data is 0 and we receive 1 and time with the probability of output data is 0, so it's 0.6 times 0.3 plus 0.4 times 0.2, so it's 0.18 plus 0.08, so the total probability is 0.26 that we receive error data.